This video is going to look at sine x squared plus cosine x squared equals 1 to determine if it's identities or conditional equations. Okay, well, I think we talked about pi in the last video for this and why I use pi, because pi is a representative number of the ratio between the circumference and the radius, or excuse me, circumference and the diameter of the circle. So I'm going to plot, and I've done this in the last video, so I'm going to just take the number as is, or maybe I won't. I think I will regress and take out the power sign. I want to change my first equation, since that's not going to change at 0. But I'll change the power sign here. And then I'll map that across everything. This is a start at the half, at the quarter, at the third quarter, all the way around. The second time around, second half time around. Beginning of the third, end of the second, 3.5, end of 3. So it shows 3 full loops of the sine wave. So get rid of that one. Let's show the cosine without the square. That's the look. It's red. Cosine would be in red. And that's a normal cosine wave. So, cool with that. Get rid of that. And that was a full loop around. Now I'm going to show the additive between. This is the first link. Okay, this is a cosine. This is a sine square plus a cosine square, or the sine square being the blue and the cosine being the red. Adding these 2 0.1s, right, and getting this point of the series. Okay, so yeah, it's adding the tenth of a pi, which is 0.3141, so on and so forth, and ends up being, this is the additive, adding these 2 at this level. Obviously, adding the first 2, sine being 0, and the cosine square being 1, this green, which is the additive, ends up being 1 also. Let me make this accurate. Really, I'm solving for a y to see if 1 is conditional or it's an identity. It tells the full story of x. So it's only telling the partial story. Let me do the first loop. So it's going from 0 up to near 0.8. 1.8 as the additive between these 2 waves, and this is the cosine, this is the sine. So let me go another, or the halfway around. This is showing the halfway around the circle, or halfway through the wave file. So this is what it looks like. I think you'll find this one interesting. because the way the cosine squared seems to keep dropping. And you'll see what I mean. Let's go a little bit further around. And that should get me to the... And it dropped to this point because it's basically adding these two waves together, and this is the lowest point so far, right? And then halfway around it's back at 1. So this is true here for the green. This is representative of the green now. So 1 is here, 1 is also here, and 1 is also here. So let's keep on. You notice that this kept going down. I like this. This is a gorgeous picture of the cosine squared. Drops all the way down to 0 itself on a continuous drop. Then it turns the corner, and this has made a loop and up for the second time and back down. So this would go all the way back down and start turning around, and this is making a full loop. That's a full cycle around the circle. Okay. Let's go down to another full cycle. You should see not the same pattern. So first cycle here to here, second cycle here to here. They're different patterns. So I like that. I tend to wonder how much it would repeat. Maybe I'll just take it to that point to see. And this does not look like this one, nor does it look like this one. It almost looks like a, well, not quite. I was almost going to call it reverse, but it's not. Okay. And I'm going to have to shift down just to extend my number system further down. And I'll do this. I'll go down and punch it in at 12. And then look at the picture. As you can see, I could extend it and keep adding it to see if anything repeats. And I'm not. But you see the idea of adding as an equation the sine and cosine. It's math. It's doable. And with the tools we have nowadays, and I know you have some of those nice calculators, but Excel has a function. It can actually show you numbers laid out side by side, what might be going on. And let me punch this down through 24. Where is it? Right here. So you can see it float through. And I think my selected area may have shrunk here. And just for giggle's sake, let me make another quick one of these. I'll delete it. Like doing this. And this way you'll see how I actually create a graph. So I'll select this full area. And I'll go where it says insert. Go to where it says scatter. Pick the bar graph that shows the points but also shows a smooth line into each one of the points. Click it. This is what hits the page. And I want to make it larger because the small one doesn't do us any justice. And I stretched it off the page. So I guess if you take it far enough, you could see some building, some cycles in the overall madness of how it cycles. And you could probably see a repeat point. We saw that was about point 0.08. Yeah, starting from 1. And looking, it might begin here, you notice this loop is reflective of the last video, how these kind of mesh up from 1 to 1 and 1 to 1. So I've seen that series before. Of course, if you're a mathematician, you might want to try to figure out why is it that way, why is the series loop in this fashion, and the graph, and of course that's what calculus helps you see, is how things change over time when you're marrying up two different type of waveforms. Well, enough said. Thank you.